Hey everyone, today we are going to learn about arc length. Okay, um, so with our arc length, we're talking about part of a circle that we want to find, that I want to highlight here in yellow, that we want to find how long that is. Before we get to diving into the formulas and how to find that, let's look back and think about some things that we've already learned about, or you should have learned about. So we have a circumference. What is a circumference? Well, back in the day when you first learned about circles, circumference is like the perimeter of the circle. It is the distance around the circle. Okay? So they're talking about this guy all the way around to this circle right here. Okay, that is a circumference. All right. If you look around the room, you'll see a poster. There should be a formula on there that talks about the circumference. Okay, we call this formula C because the C stands for circumference. Okay, and on that circumference we have a couple different formulas. One of them that we're going to be the one that we'll be using is 2 times pi times our radius. Okay, every once in a while you'll see another one. Okay, and it works just fine too, but for the purpose of our formula today for arc length, we're not going to use it, but it is pi times the diameter. Okay, so for the circumference, we need the radius. Okay, that's from the center to the edge. Okay, so in that circle on the top, underneath the word arc length, let's label our radius. Okay, if you guys notice on that circle, that top circle, I have a portion of that. I have an arc. Well, if you remember about yesterday and the day before, we were talking about arcs have measures of angles. Okay, and that is talking about this part right here. That has a certain measure. So we're going to use that. And if you remember in trigonometry, we had a symbol that represented angles. That symbol was theta. It was that Greek symbol. Okay, so it's coming back, we're seeing it again, and it's still representing angles. Okay, so for these blanks down here, the arc length is a portion of, okay, so when we look at that bolded line up here that I'm going to do in blue, okay, this part right here, is that inside the circle, or is that on the edge of it? It's on the edge. Well, what we were using to find the distance on the edge was the circumference. So the arc length is just using a portion of the circumference. Okay, of a circle. Okay, so if we think about that, we want to think about a portion of that circle. So how many degrees is a whole circle? When we talk about that, a whole circle is 360 degrees. The whole always goes on the bottom of a fraction. Remember that. Okay? Now we're going to have a part of that that's on the top of that fraction. Well, what symbol did we use in that picture there to represent part of the circle, to represent part of the angle? We used theta. Okay? So part of our equation is going to use theta over 360. That's telling us, hey, I'm only going to use that section of the circle. I'm not going to use the rest of it. Okay? Then we got to find that distance. Well, that distance around the circle, well, we said that that's the circumference. So if I multiply the portion I'm using by the circumference, so theta over 360 times 2 pi r. And that's going to be our formula that we're going to use today to find arc length. Okay? One really important thing to remember. Okay? Arc length down here and that little symbol right there means does not equal. It's no good. Arc length does not mean arc measure. Okay? Remember that. That's very, very important. So if we're talking about find the measure, you're going to use the skills that we did yesterday to find the degrees and those tricks about the whole circle and part of the circle, okay? Today, we're going to focus on the length of that arc, okay? How big is it? All right, so go ahead and open up your foldable or inside of it, and we're going to take a look over and onto the left. So we're going to review a little bit about the circumference. Okay, circumference was the distance around the circle. So I want to find out how long is it all the way around this circle here. Okay, so we're going to use our formula. All right, circumference equals 2 times pi times the radius. Okay, and the only thing that I don't know what it is the radius. Well, in the picture they tell us, well, how much is it? Well, it's 11 feet. Okay, so let's go ahead and plug that in. So we have the circumference equals 2 times pi times 11. Okay, so we can take that value and we can plug it right into our calculator. So go ahead and plug that guy in. So we have 2 times pi times 11. And we get 69.1 feet. Okay, and when we're doing measurements, it's just plain old feet. Okay? Alright, so let's go down here to this next guy. Alright, well, we need to find the circumference, so let's go ahead and write our formula. So C equals 2 times pi times r. Well, I got this line that goes all the way across. I didn't have that on the one before it. I went from the center to the edge. So if it goes all the way across, this is called a what? A diameter. Well, I need a radius. I don't need the diameter. So what do I do to that diameter to find the radius? If you remember correctly, we divide the diameter in half. Divide it by 2. So off to the side, I'm going to write 5 divided by 2. And type that in the calculator, and you can hit Control Enter to find out what that decimal is. Decimals are okay. And when you do that, you should get 2.5. So that is what our radius equals. Our radius is 2.5. So we're going to take that value, that 2.5, and we're going to plug it into our r up there. Okay? So let's go do it. So circumference equals 2 times pi times 2.5. So there's our formula. Let's go ahead and plug it in. 2 times pi times 2.5, and you should get a circumference of 15.7 meters. Now, what we just did is we found the distance. How long is that distance all the way around the circumference? Around the circle. That's for the whole circle. Okay? So if we think about this, alright, you guys don't have to write this down. I'm just going to sketch it down here. So if you think about that, if we talk about a whole portion of a circle, so how many degrees is a circle? 360. If I'm using the whole thing, I'm going to have 360 on top times 2 pi r. Okay, well, if I type 360 over 360, that's 1 times 2 times pi times our radius. Well, 1 times 2 is 2 pi r. So there's kind of how we get the formula for our portion, okay, and our circumference. Alright, so let's go scoot over to the right side, and we're going to start using the arc length formula, okay? So go ahead, write it at the top. We have theta over 360 times 2 times pi times our radius. Okay, so in this first example, they ask us to find the arc length of EF. So EF is from here to here. Okay, well, they give us all the information we need. Our radius equals 6, and our theta equals 120 degrees. So let's take that information, let's plug it into our formula. So when I plug it in, It's going to be 120 over 360 times 2 pi times 6. Okay, now all you got to do is type that bad boy into the calculator and you'll find your answer. Okay, so parentheses 120 divided by 360, alright, and times 2 times pi times 6. And when you do that, our arc length of EF is going to be 12.56, and that's going to round to 12.6. Now I'm finding length. Am I going to measure this in degrees or am I going to measure this in meters in this problem? Measure length in meters. So it's going to be 12.6 meters. Okay, and there's our answer. Alright, so let's go down to this next one. Alright, well, this is the next example. Oh man, they say that the diameter is 24. Okay, let's go ahead and draw a diameter in this using that point C. So from C to the center to the other side, that's going to be 12. That whole thing, that whole thing is going to be 24. But I don't need that whole part, do I? I just need from the center to the edge. So I need half of it. So my radius is going to be half of 24, which is 12. Okay, and they're wanting us to find the arc length of CD. So from C to D, so my degrees, my theta is going to be worth 60. So go ahead and plug it in. So we have, we have 60 over 360 times 2 pi times our radius. We said our radius was 12, so I'll type that in there. Okay, so now what we can do is type this whole thing into our calculator. 60 over 360 times 2 times pi times 12, which should give us 12.56, which rounds to 6, and we measured this in centimeters. Okay, we're not going to use degrees on this. We're finding distance on this, so we're measuring distance with centimeters. We measure angles with degrees. Okay, so that's going to be a big takeaway for today. Make sure you're using the correct units with this. Alright, so let's go down to some words here. Okay, so this next example, a circle has an arc whose measure is 80 degrees and whose arc length is 274.46 pi inches. What is the diameter of the circle? So with this problem, they're having us work backwards. We won't really be doing this, but I'll show you guys how it works. Okay, so for our arc length, okay, so I'm going to have C represent our arc length equals, I'm going to just write our formula out. Theta over 360 times 2 pi r. And let's look at the information they give us. Alright, they give us this 80 degrees. Well, that's going to go for my theta right here. Okay. Next, they give me an arc length of this. Alright, well, you can type that into your calculator and actually get a number for it. But for the sake of this, let's not do it. Alright, so I'm going to plug that in for my C. So what I have to find out is what the diameter of the circle is. So if I plug these guys in, so 276.46 equals 80 over 360 times 2 times pi times our radius. Oh, and I forgot my pi right over here. Sorry guys. Just squeeze them in. Okay, since I have pi on both sides, if I divide both sides by pi, they're both going to cancel out. So I don't actually need them. So now I have 276.46 equals 80 over 360 times 2 times our radius. That's what's left over after we canceled out our pi's. Okay? So next, I can put some things together. I can put this 80 over 360 times 2. Okay, so let's go ahead and do that. Type that in your calculator. If we have 80 over 360 times 2, okay, and that gives us a really big decimal. Okay, so and that decimal is point 44 times our r equals 276.46. Alright, to get r by itself, I gotta divide both sides by 0.44. So 276.46 divided by 0.44, and we get that does seem right. Okay, we get 628.3 equals our radius. Okay, that's as far as I want to go with that problem. We're not going to come across this on tests or quizzes or anything like that, so I'm not going to hold you guys too far accountable for it. Just kind of know how the equation works, how to set it up and take information and plug it in. That was the big thing I wanted you to do. Okay, so now this last one, it's just like the previous. I don't want to worry about it. Let's just go ahead and scratch that guy out. Okay? Alright, you guys. So that's the notes for today. Remember, our formula is theta over 360. Theta represents the angle times 2 pi times our radius. Alright? And whenever we start mixing this up here in a little bit, remember, arc measures are not the same thing as arc length. Alright, I'll have the quizzes for you guys to work with, the code to type in. Go ahead and get working on it, and I'll see you guys on Friday. Don't forget that we have a quiz. Peace out.